Hey class, this is Mr. Devsky, and we're doing balancing of chemical reactions today. Yay! Okay, I hope to get 3 of these done. I got a 15-minute time limit on this app, so I'm going to dig right into it. If you have any questions, bring those up in class. Okay, the first one, and these are all from the book, but I don't remember what number they are, is CS2, and we're going to write the skeleton equation first, okay, plus Cl2. Produces CCl4 plus S2Cl2. So you should be able to name all these things. This is carbon disulfide reacting with diatomic chlorine to form carbon tetrachloride and disulfur bichlorine. The first thing I always do is draw a little line down the middle, and I'm going to take an inventory of all of my atoms. Atoms in the products on the right, atoms and the reactants on the left. So I need to list each element separately, C, S, and Cl. On the left-hand side, it's obvious I have 1 carbon, 2 sulfurs, 2 chlorines. Just multiply the coefficient in front by the subscript. On the right, we have 1 carbon, we have 6 chlorines, and we have 2 sulfurs. Okay? So here, remember that there is an invisible coefficient of 1 in front of all 4 of these when we start with our skeleton equation. The only thing we can change when we do balancing of chemical reactions is the coefficients. You can't change the formulas because that would be talking about a different chemical reaction. So what can I put in these 4 boxes that's going to make the left side and the right side equal to each other? So first off, you can see that chlorine is unbalanced, and the only place I can change that is by putting a 3 right in front of the Cl2 on the left-hand side of the reaction. When you do that, I have 3 times 2. Now I have a total of 6 chlorines. And notice, use my highlighter here, my carbon is balanced, my sulfur is balanced, chlorine is balanced. My answer looks like this. CS2 plus 3 Cl2 yields CCl4 plus S2Cl2. And you could read that back as carbon disulfide reacts with 3 moles of diatomic chlorine to produce 1 mole of carbon tetrachloride and 1 mole of disulfur dichloride. And if I asked you to type this into the Chromebooks as your answer, usually we just put the coefficients. So it would be 1, 3, 1, 1, and that way I can glance at it and find out if you got the right answer. Let's do another problem here. Okay, this one's just a little bit more involved. My skeleton equation is as follows. MnO2 manganese 4 oxide reacts with hydrochloric acid to form manganese 2 chloride plus oxygen plus water. Coefficients can go here. That's the only place we can change numbers. Okay, so we got our inventory right down the middle. We got manganese, 1 on the left, 1 on the right. We got oxygen, 2 on the left and 3 on the right. We got chlorine, 1 on the left and 2 on the right. Okay, so it's kind of obvious here. Whoops. It's kind of obvious to me anyways that I wrote the skeleton equation wrong. So this oxygen has to be a chlorine. And if you ever get stumped on one of these, make sure you wrote it down right. Okay, for crying out loud, that will really mess you up. Chlorine, Cl2. Okay, so that changes my inventory. My inventory now says I have 4 chlorines on the right-hand side. Now we're good to go. Okay. And only 1 oxygen. And then we have some hydrogen. One on the left, two on the right. Okay, with all one coefficients, this is what we get. Now, I'm going to always encourage you to save oxygen for last. Oxygen is so prevalent in so many different things that if you save it for last, usually it'll just fall into place. If you try and start with oxygen, sometimes you spin your wheels because there's so many different changes going on in the chemical reaction. So I can see that my main difference here is going to be chlorine. I'm going to start with that because I can see that I could put a 4 in front of the HCl, and that's going to change this 1 chlorine to 4 chlorines, which is good. That's what I want. It's also going to increase my hydrogens to 4, and that's okay. We can deal with that as well. Okay, on the right-hand side now, I can see that I've got half as much hydrogen as I do on the left-hand side, so I'm going to double the waters since that's the only place I have hydrogen on the right-hand side. If I put a 2, oops, put a 2 in that, put a 2 in that, put a 2 in that box. Okay, that's going to double my hydrogens to 4, and it's going to double my oxygens to 2. Okay, so what's the next step? The next step is look and say, okay, I got 1, 1, 2, 2, 4, 4, 4, 4. Now I notice I'm done. Okay, it's just like, whoa, that was too easy. Okay, I've got everything balanced, all 4 elements, and I can write my full answer out as MnO2 plus 4HCl yields MnCl2 with a 1 coefficient. This thing keeps popping up. I'm sorry. I don't know why. Plus Cl2, 1 coefficient, plus 2H2O. Okay, and there's my final answer. Or again, I can use just the coefficients to be 1, 4, 1, 1, 2. If you use this kind of nomenclature for your answer, make sure that your elements and compounds are in exactly the same order that they were in the question. Otherwise, 2 of those numbers might be transposed and I might mark it wrong. Okay, the third one of these is called a combustion reaction, and they can be a little bit tricky because of the oxygen thing again. So let me give you one here. This is also from the book C7H14O2 reacts with oxygen to produce carbon dioxide and water. Now, if we do our inventory here, you'll see it's all carbon, hydrogen, and oxygen. And on the left-hand side, 7 carbons, 14 hydrogens, and 4 oxygens. On the right-hand side, 1 carbon, 3 oxygens, and 2 hydrogens. And when I look at this, the obvious place to start is carbon. On combustion reactions, always save oxygen for last and start with carbon. So here's my carbon. I'm going to put a 7 in front of the CO2 so I can get 7 carbons on the right. That's going to change my oxygen. 7 times 2 is 14, plus 1 is now 15. Don't forget to count everything up. So I've got 7 times 2 plus 1, 15. Now I'm going to take care of hydrogens. You can see I have 14 hydrogens on the left and 2 on the right. Well, if I multiply H2O times 7, you'll see that now I can get 14 hydrogens on the right. And my oxygens are going to change again. So now I'm going to go 7 times 2 is 14, plus 7 times 1 is 21. So my number of oxygens is 21 now on the right-hand side. So the only thing that's unbalanced is the oxygens here. And here's the trick. If you know a little bit of algebra, you can use algebra to solve this problem. You can solve this problem by doing a little bit of trial and error. Okay? So there is some magic number that's going to go in front of the O2 that's going to make those oxygens equal to each other. You don't want to change the coefficient in front of the C7H14O2 because if you do, you're going to have to restart again because it's going to change your carbons and it's going to change your hydrogens. So What's the magic number? If you want to use algebra, it'll look like this. The O2 means that I'm going to have 2 times the coefficient, 2x, plus the 2 oxygens from the C7H14O2, and that is going to have to equal 21. So again, if I can solve this for x, that's going to be the coefficient for O2. And you can see it's going to be 2x equals 19, x equals 19 halves. I'm going to write that up there and finish the problem out. So you say 19 halves. How can you do that? I thought those coefficients have to be whole numbers. They do. Whole number ratios, remember. So 19 halves, would that work? 19 halves times 2, because there's O2 is a diatomic molecule, means I'll have 19. 19 plus the 2 oxygens here is going to give me 21. So that works. The problem is I can't leave 19 halves as my coefficient. How do I get rid of it? The problem is I've created a problem in order to get things balanced, and now I need to get rid of the problem by getting rid of the fractional coefficient. The way we do that is by multiplying everything by the denominator of that coefficient, in this case 2. So if I take every coefficient in this reaction and multiply it by 2, I'll get rid of the 19 halves. The first one is going to be 2 times 1. And we write 2, C7H14O2, reacts with 19 O2s. When I multiply this one by 2, the 2's cancel out, and I end up with 19 for my coefficient. Yields 2 times 7, 14 carbon dioxides, plus 2 times 7, 14 H2Os. Okay, so those look like big numbers, but this is how it sometimes works out. Okay, and my coefficients are 2, 19, 14, and 14. If you want to check your answer, we would then take our new inventory on our answer here, and we can see that we're going to have carbon, hydrogen, oxygen. The carbons now, I have 2 times 7 on the left, 14. Hydrogen is 2 times 14, 28. Oxygen is 19 times 2, which is 38. And 2 times 2, which is 4, for a grand total of 42 oxygens. On the right-hand side, we're going to have 14 times 1 for 14 carbons. 14 times 2 plus 14 times 1. That's going to be 28 plus 14, which happens to be 42. And then the hydrogens are going to be right here, 14 times 2, 28 on the hydrogens. So that's a quick lesson. It took all of 13 minutes on how to balance reactions. And you'll get some practice in class, but here's 3 examples you can go back and review at your leisure as many times as you want. And remember, save oxygen for last. Have a great night, and we'll see you in class tomorrow.